Hi guys. So this time I want to show you. First, I have to mute my sound on my on my computer. So this time I want to show you how to build your own PowerSharpPack script, and afterwards we're gonna take a short look on reflective PE injection, how it can be used, why it should be used, or where are the possible use cases for it. And yeah, that's pretty much the topic for today. Um, PowerSharpPack is one repository which I created. Yeah, I don't know how long ago when I created it. It's about 2 years or something like that. But basically, the process to build your own PowerSharpPack script is pretty easy. Um, First of all, what is it, or can you do with it? It's more or less just an or many different C# assemblies, which can be loaded from within a PowerShell script. And yeah, in general, it's just more or less about these 5 steps here. You need, or if you have one C# assembly or C# stager for your command and control framework or whatever, then you can take this one and encode it or make a byte array out of it or something like that. And then you can embed this into a PowerShell script, decode it on runtime, make a byte array out of it if you don't save it as a byte array. And then you can basically use system reflection assembly to load the C# assembly which you want to use. Yes, this stream will also be uploaded to YouTube afterwards. Yeah, in general, to get an overview how every or each of my scripts here is structured. Most of them are in the moment gzip compressed and afterwards base64 encoded. So it's the executable itself, the C# assembly, that is gzip compressed, afterwards base64 encoded, and this is on runtime base64 decoded. Afterwards, it's gzip decompressed, and this decompressed stream is basically the byte array of the C# assembly, and we can copy this into a memory stream object and afterwards load it via system reflection assembly, which is pretty much the way that every or most of the command and control frameworks and or everyone uses in the very end this function here to load a C# assembly. At least I self don't know any other function to do that, which can take a byte array as input and to load it reflectively. Yeah, afterwards you can execute the C# assembly by just using this. Well, I don't know the English word for this special character. I don't know it, but this one, then the namespace name of the assembly, the class name, and the function name with 2 double points in between. And if you have some arguments for the assembly, then you can just use a variable in PowerShell and split this up with the function split, so that if you have, for example, yeah, not only one word to give to the assembly as a parameter, then you have to use split in this case. This here is more or less, you don't need it but it's nice if you want to take the output of the assembly and if you want to store it somewhere. For example, if you want to store the output of an assembly to a disk, which I do in many points in WinPoint, for example. If we take Invoke Rubius, for example, then you can see that, oh no, in this case I'm using outfile, so this is a bad example. Seed belt. If we take a look at seed belt, then I'm also using output file as argument in this case. But for other C# assemblies, like for example Watson or Sharp Web or Sharp Up, I'm just outputting this into a text file. And if you want to do something like this, then you need these 6 lines, these 3 in front of the execution for the assembly, and these 3 afterwards. Because if you don't have them, you cannot output the output from the C# assembly anywhere. And if you use it, you can do that. Okay, that's more or less the same template that I use for every single script in this repository. There are some examples that still use base64 encoding only and no gzip compression. Just to tell you the difference, if you use base64 encoding only, you can still use these scripts in PowerShell version 2. So if you find PowerShell version 2 enabled anywhere, you can use base64 encoding there, because the convert from base64 string function here is available in PowerShell version 2. So, but if you don't have PowerShell version 2 or PowerShell version 5 or something newer, which is the case on most modern systems, and if you don't or if you cannot do a downgrade, then the gzip compression version won't work there. So gzip compression has two, more or less, maybe one. The main advantage is that the script is getting smaller. That's the sense of compression. In addition, it's at least a little bit also is, I would not say stealthier, but the signature of the assembly itself cannot be that easily grabbed out from the script if you gzip compress in addition to base64 encoding. But I would not say that this is super good, because you can always just decompress and then you have the old value. Yeah, if we take a look, or if we just want to see if this can be easily loaded from a new PowerShell window. No copy paste. Then we'll see that all of these scripts are flagged by AMSI, Anti-Malware Scan Interface from Microsoft. This happened, it was not from the very beginning on, but this happened somewhere when the repository became more popular. And they built, it's basically one signature and that's the same for all of the scripts. And I'm also going to show you how to modify your script so that they are not flagged by AMSI anymore. But the question was, or what I wanted to show you initially is how can you build your own script in this case? And I have one example C# assembly which I want to show you today, and how to make a PowerShell script out of it, or how to embed it into a PowerShell script to load it reflectively. And this is sharp bypass USC. It's an assembly which uses the most well-known, I would say the most well-known UAC bypasses, and you can choose one of those event viewer, foot helper, computer defaults, and so on, and pass an as an argument you can pass an base64 encoded command, and this will be launched with elevated writes. So if you got a shell on some administrator's client computer, and but it's still not elevated, then you can use this tool to elevate your privileges and to get an privileged shell, for example, back, or to just execute one command um, with elevated privileges. So just like always, if you want to do something with an assembly, or if in this case we need to do some modifications to the assembly to make it work. The first thing is that you need to set that this is not 100% necessary, but it's helpful if you set the class and main method to public, especially if you use this template, because if you don't set them to public, then you cannot load the function this way. There are still other ways, like for example, you can search for the entry point and then you can say execute this entry point. But if you don't set it to public, then you cannot use this method to specify the namespace, the class name, and the function name. So the first thing we're gonna do when this is loaded, takes too long. Yes. I think this is still the disk, that everything is so slow. After this stream, I'm gonna have to burn out in a moment. There's my VM is just very slow today. In this case, for many other scripts, yeah, you can also just read it in the README, but I took a look at the pull requests for the scripts, merged them into the main assembly, and one more important point is that if you want to use a C# assembly from PowerShell, you need to remove all environment exit statements, because if you don't do that, then and the program flow runs into an environment exit, then your whole process will be killed or exited. So this is pretty bad if we use, for example, Covenant as command and control framework, and if we load one script via PowerShell, whatever, then when environment exit is called, then the whole process is killed, and we lose our grunt. So we don't want that to happen. And therefore we have to search for environment exit and remove them. In some cases, removing environment exit will have some bad effect, like for example, if you don't pass the right arguments, and if you skip environment exit, then the program will still run forward and forward, and so you have to also take a look at what is happening after that, and maybe modify the source code so that no unexpected behavior occurs in this case. So namespace is sharp bypass UIC. I just set the class name sharp bypass UIC to public. It was not public before. And what I nearly always do, just for fun, it's not necessary, but it's just for me and for my fun, is I replace all the main assembly name with an leet-speak variation of it. So in many cases, this is already enough. If you watched my C# AV Evasion 101 stream, then I also showed this trick. It's not really great magic or something like that, but this is in many cases already enough to avoid a signature for the assembly and or an AMSI signature. So if we take a look now, the main function in this case is also not public by default, so you also have to make the main function public if we want this to work. And in the next step, we can see that system environment exit is used in this script. And I will just show you what happens if we use it with these functions so that you can see it. So I'm going to compile this. So we got a compiled version here. If we just execute it without any argument, we'll get a short description. If we use -h, we'll get the same. And in both cases, I think that the environment exit should be called. So if in the next step, we're gonna gzip compress and base64 encode this assembly so that we can embed it into our PowerShell script. I'm using this PowerShell script helper function, whatever, to do that in the most cases, or in all cases, if I want to gzip compress and base64 encode. And I already put it into the corresponding directory. No, it's not temp. Stream PowerSharpPack. PowerSharpPack. I got it here. You can load that, and afterwards you can use the function to complete gzip compress. You can specify an input file. In this case, we want to gzip compress our newly compiled sharp bypass UIC assembly. And this script will do that, gzip compress it, base64 encode it, and afterwards it will put a new or a text file into the same directory with the new extension gzip base64 txt. And this text file now contains our gzip compressed base64 encoded sharp bypass UIC assembly. And if you want to build your own script this way with any tool, then you can use one of the scripts from my repository and use this as a template, for example. Sharp bypass UAC in this case. We want to replace this string here with our newly created string. And then we have to, in addition, because in this case we're not executing bad potato with the class name execute rectangle and the main function, but we want to execute sharp bypass UAC. With the class name sharp bypass UAC. And the function is still main, so we can leave that. We can make it uppercase, but this really doesn't matter at all. Okay, to show you the environment exit problem, I'm gonna put this into this directory here. Sharp bypass UAC. And we try to load that. It's still flagged. So now I can show you how to get rid of this AMSI detection, which is basically really easy. In this case, we first of all replace the variable names. Can replace a with whatever, some string. We can replace output with some other string. We can replace decompressed with another string. We can replace byte out array with something. And this RAS is replaced with one more string. And then we should be fine for variables. There's one trigger that has the variable names embedded. So if you change them, you get rid of this trigger. The next trigger is in this point. I did do this many times before, so I know where the general trigger for this template is. And it's always flagging for base 64 string, then the magic bytes of a C# assembly, and then the ending. So we can also change this ending here and split it up. Yeah, and just to be sure, we can, for example, also move some or replace some lowercase characters with uppercase characters, and some to also change the signature in this case, because there also were some signatures for the gzip stream IO compression and so on parts. And if we do that, and if we make here this and save it, we can try it out, and it's not flagged anymore. So to get rid of this trigger, it's pretty much the same process all the time. Split up the magic bytes, split up the end bytes, change the variable names, and yeah, some lower uppercase characters to get it working. So in this case, we still cannot execute it because we get this exception here. And this exception says something like, I could not load file or assembly with 25,000 bytes because it's an incorrect format. And this message has nothing to do with what it tells you, but actually is the anti-malware scan interface on the .NET side. So if you execute or if you load any C# assembly via system reflection assembly load, then it will get scanned by the anti-malware scan interface on the .NET side. And in this case, we bypass the AMSI signature for the PowerShell script, but the byte array, which contains sharp bypass UAC, is still flagged by the anti-malware scan interface, and therefore we cannot load this assembly. I wrote a blog post with a description why this occurs and how to avoid it. And to make it short, you have two ways to oh, it's Notepad. You have two ways to bypass this. The first way is patching AMSI DLL in memory. If you do that, you will bypass AMSI for the whole process, and this will also bypass AMSI for loaded C# binaries assemblies because they are also loaded in the same process. And as an alternative, you need to modify the source code to get rid of the anti-malware scan interface signature. The first thing is easy. The second is also not complicated, but I can show you that it's working if we bypass the anti-malware scan interface in this case. This is the only AMSI DLL in memory patch on AMSI fail, so you have to look for this raster mouse AMSI scan buffer patch, and if you find it, oh no, I did something really bad here. Okay, this should have worked. So if we now execute sharp bypass UAC, first we will do that with passing the parameter help. Yeah, you see that the process died, and that's because if we but there was not the same message anymore that the bytes could not be loaded, so we actually bypassed AMSI, but our whole process died because there is a system environment exit if we press the help argument. Then it will give us the description, and afterwards it will exit, and this exits our whole process. To get rid of this, we can replace system environment exit with, for example, return, because return will not kill the whole process. There were 3 more occurrences in the whole project. To search and replace in the whole project, you can press Control, Shift, and H, and then you can replace everything in the whole project. So we replaced the system environment exit with return in this case. And we want to now get rid of the anti-malware scan interface signature for it. We're also going the second way now to modify the source code to oh, it failed. I see that we always notify. This will always fail. Okay. This is interesting. Do we need the foodie? It compiled successful, and now it doesn't want to compile anymore. No foodie weavers found. Looks like I broke something by. But it makes no sense for me that the project doesn't compile after replacing system environment exit with. So for the moment, I'm just going to uninstall foodie. Okay, now we were able to compile this. But we have to still embed foodie again, because if we don't do that, we don't have the ndesk library embedded. So we're gonna check the file for a signature now. No signature found, so maybe it was enough to not embed ndesk options to get rid of the anti-malware scan interface signature. Looks like that. So I'm gonna reinstall it for the moment. We could also, we have a second option. We could also load ndesk options on runtime at first, and afterwards load sharp bypass UAC. This should also be possible. But first of all, I would like to check if this really was the signature. Build is also successful. We don't have the DLL in this directory anymore. Let's see if this, yeah, okay. With ndesk options, it's triggered. Without ndesk options, it's not triggered. But if we take a look at the trigger in this case, It's the food helper executable and software Microsoft Windows. So we can take a look at that in the source code. Software Microsoft Windows. Oh, did I just replace it? Or did I just search for it? No, it was just search. Always notify. Don't think that this is the point because I don't see food helper in this case. So in this part is the food helper. We can just try to split this up, for example. String ASD. This is ASD plus food helper. Let's see if this is the trigger or if this was the trigger. Yeah, okay. We just removed this anti-malware scan interface trigger, and by just modifying this one line, and now we should be fine. We also have no system environment exit anymore. So we can go for another approach of gzip compressing it. C stream PowerSharpPack gzip compress. Input file is the same. This one. Now we have new timestamp on this text file. We can replace our old string for the assembly with the new one. Okay, what did I do wrong here now? This is missing. We are again changing or splitting up the magic bytes at the very beginning here because they are one of the PowerShell triggers. And the string at the very end. Gonna save this. So we have real-time protection enabled. Anti-malware scan interface is active, as you can see. And we're gonna load sharp bypass UAC. Oops. Invoke sharp bypass UAC. So there's no AMSI detection for the PowerShell script. If we don't pass any parameter at all, in this case we have the default parameter who am I from bad potato. We don't want that. So I'm going to save this without the default parameter who am I. Instead I'm going to use -h for the help me. I have to reload that. And we get the help me, and our process didn't die because we replaced the system environment exit statements with return. So this should now work as expected. And we can use Well, I don't have the syntax for it in my head, but if we want to launch calculator as administrator via event viewer UIC bypass technique, then this should be fine. Okay. Now Defender detected the UIC bypass method. So this must be some heuristic detection or something like that if event viewer exe is called and if some these or that registry parameters are set before, then kill the process. It will be something like that. Stream PowerSharpPack, PowerSharpPack, Sharp bypass UAC. Just to verify that it's working, I don't plan to modify this UAC bypass to get rid of this detection by Defender now, because this would need more source code level modifications in the moment. Instead, I'm just going to try another technique. Let's see if food helper is working. It's the same. It's the same, but our calculator as administrator is still spawned. So it worked, but our process was killed because Defender detected the UIC bypass itself. Yeah. In this case, I'm not gonna modify the source any further. As I said, it's pretty bad that the process is killed if you execute it this way, but this script is now still not detected by the PowerShell anti-malware scan interface and by the .NET anti-malware scan interface. So this is pretty much fine to be used. If you have another AV and not Defender in this case, then you may not get your process killed if you use this. You can also try to use the other ones here, like computer defaults, SD, CLT, SLUI, or disk cleanup. Maybe one of them doesn't kill the process in the case of Defender. I don't know, and I didn't want to test this in this stream. But I'm pretty sure that it's somehow flagging you created a new registry key here, and this contains a command. You run event view afterwards, and this will get detected. It's pretty bad. Just want to take a look at this. Normally it's cleaning up the registry entry afterwards here. If it was killed before doing that, then the registry entries should still be there. So it's current user software classes. It's current user software classes MSC file. Shell open command. Ah, looks like this. Still looks like it was able to delete it. but the process was still killed. Yeah, so now we just created our own new PowerSharpPack binary by bypassing AMSI for PowerShell and bypassing AMSI for the .NET assembly, which is contained. And that's pretty much the whole process. So it's very easy, and therefore this stream will be one of the shorter ones. I don't know how long it takes for reflective PE injection, but it will not be much longer. Especially no one has questions here, so this will be one of the faster streams, I think. Normally I'm also adding the description of the tool and a link to the script itself. The advantage of building your own script and of not using this repository should be obvious. Sure, it's easy to use them here, but for all of them, you need to patch AMSI DLL in memory, and in the one, there will be one moment where the AV or the EDR product will prevent you from patching the anti-malware scan interface DLL in memory. I'm pretty sure that this will happen at one moment somewhere in the future. And if that happens, you cannot use any of them here. Or if you just don't trust me that they don't contain any malicious code here in this string, whatever. If you just want to be sure that you know every part of the code, then you should compile your own C# binary, modify it to your needs, bypass signatures for the assembly, embed it, and then you are fine to go to use it from PowerShell. Yeah, that's pretty much the first part of the stream. This was an easy one from my point of view. The next one is reflective PE injection. I know that other people like Flangvik, for example, also did a stream about reflective PE loaders and about reflective PE injection, but I don't know what. I think he was executing backstep in memory in his stream. I took a short look on it. In this case, I'm first going to show you what the difference is, or what in general where it's for, and I'm going to show you 2 examples on how to execute portable executable files in memory. The main reason for that is pretty much the same than the reason for embedding an assembly in a PowerShell script, for example. If you just want to stay in memory, then if don't want to drop the binary or any binary to disk, then for assemblies, it's your way to go to use assembly load in any stage. In the most cases, the command and control framework will have one option to reflectively load C# binaries, and this will in the very end still use this function. If you're not using a command and control framework because you're doing a penetration test and you just don't need a command and control framework there, then you're fine to go to patch AMSI and use the script, and you still stay in memory and you evade or most of the AV vendors by doing that. And yeah, that's pretty much the use case of it. The difference between an assembly and a portable executable is just the programming language. The assemblies are C#, C#, written in C#, And portable executable files are, yeah, many other languages. Like mainly it's about C, C++ binaries, everything that's written in C or C++. So everything that's C or C++ is mainly a portable executable and cannot be loaded via assembly load, obviously, because assembly load can only load assemblies. I know that binaries written in Go can also, Go language can also be loaded reflectively. As third, languages like NIM, for example, can be loaded reflectively, because in the very end, NIM is compiling to C or C++. That's your choice when you compile a NIM source code. Compiles to C or C++, so this is pretty much the same than the first. Yeah, I didn't use many more, but there will most likely more on other programming languages that end up in the same format for portable executables that can be reflectively loaded. Yeah, and everything that's written in these languages can still be loaded in memory without touching disk if you're using a reflective portable executable loader. And the at least first reflective PE-Injection script loader, however you call it. Oh, that's bad for me. That I knew and that I was using, and maybe this is the case for many people in the community, is Invoke-ReflectivePEInjection. And you just saw that opening up this script was blocked by Defender, although this folder is in an exclusion. And that's the case because Defender in general has a pretty big problem with this string. If you open up any PowerShell script with Invoke-ReflectivePEInjection, it will have strange behaviors and will be killed or forbidden. So the first thing we do if we want to use this, at least if we use a system with Defender enabled, is replacing this function name with something else. In this case, we can use whatever. And now we have invoke whatever. I'm going to save that again just to prove that this can now be opened. PE-Injection, reflective PE-Injection. No, it's still the same. Damn. Maybe because of the name. Yeah, it's because of the name. You cannot open up any PowerShell script that is named Invoke-ReflectivePEInjection. So it's the file name in this case. Yeah, and this script is originally from PowerSploit. PowerSploit is archived now by at least 1 or 2 years and has no support for 4 or 5 years. But this script still works smooth and it's still really good way to use it from my point of view. If you don't have to care for detections because of using pinvoke. In this case, the reflective PE-Injection is using pinvoke, so it's using kernel 32 functions to to load the portable executable into memory section per section, and it's using virtual alloc, it's using write process memory, I think, or just memcopy, load library, get process address, virtual free, virtual protect, and it's using create remote thread, and using those kernel 32 functions is, if you want to stay stealthy, it's not a good approach, because if you saw some of my other streams or read blog posts about EDR evasion, something like that, you would have heard about hooking, and all these functions will most likely be hooked by antivirus vendors as well as EDR vendors. And if you use this script, then it will most likely pop many alerts, especially depending on what you try to reflectively load, because in the most cases the executable is analyzed and not the script itself is the bad point, because it's also possible to obfuscate this script. Then this script will not get detected that easy, but the executable that is or should be loaded in memory can still be detected easily, because it's in clear text if you copy it into memory. So how do we gonna use this, or how can we use this? To load a binary, or as an example, I have two binaries here, which are Mimikatz versions generated with my obfuscator bash script, which I created some time ago when writing this blog post here, building a custom Mimikatz binary. I will paste it into the chat, or I can't copy paste into the chat. Yes, I can. In the very end of this blog post, I shared a bash script just to give you full insight into what I'm doing here. There's a bash script. Where is it? Ends up in this gist. Yeah, it's this one. You can still use this gist file to replace several strings in the Mimikatz source code, and to build your own custom Mimikatz binary, which still works fine and evades many different AV vendors. It looks like many didn't care about the blog post and or the script, or they didn't test it. We can take a look if this is still flagged by, or if there's a signature for the file in this case. If we use thread check on it, it's in the folder PE-Injection, and it's something like Q whatever. Oh, this is indeed detected by Defender. So at least Defender added some new signatures to detect this. So I'd need to put more strings in it to make it undetectable again. But that's not what we want to do in this case. In this case, we want to load this binary reflectively, so in memory, to avoid exactly this signature. And you can do the same with a normal Mimikatz binary. If you do that, it's more likely to get catched by an in-memory scanner function. So if the antivirus vendor scans the memory after, for example, a create remote thread is called, then it will most likely detect Mimikatz if you don't make any modifications to it. And yeah, so let's just do or use the same approach here like we did for our C stream PowerSharpPack PE-Reflection. We're gonna go into the PE-Injection folder and nope, one folder back, because we should have our gzip encrypt compression and base64 encoding function here. I'm gonna load that, and then we will compress and base64 encode our Mimikatz executable here. So this is done. We have a new text file with our Mimikatz executable, which is gzip compressed and base64 encoded. And we can use this. First, we're going to do it manually, just to show you how that works. Stream PowerSharpPack PE-Injection PE bytes IO file read all bytes. We want to read all bytes from this file. So now PE bytes contains or is a byte array that contains all the Mimikatz, or that contains the obfuscated string replace Mimikatz version. In this case, if we want to load invoke whatever, which is Invoke-ReflectivePEInjection, we will still get a message that this is caught by AMSI. We can modify that so that it's not detected anymore, and I can do that in like 10 minutes or something like that, because it's I did that in a workshop for my colleagues on Friday, and it worked pretty fine against Defender. Defender didn't detect the custom Mimikatz version anymore, and it was even not flagging it via in-memory scanner, which wondered me. So I did pretty much the same topic which I do here now on Friday for my colleagues. So we just bypassed AMSI. We load invoke whatever, and after loading that, we call invoke whatever with the parameter PE bytes and our custom Mimikatz executable. And if we do that, you can see that Mimikatz is loaded, and it's not loaded from disk, but it's instead copied into the memory of the current process, every section per section. Then all DLLs or library files that are needed by Mimikatz are loaded, and afterwards it's executed in memory via create remote thread. And privilege debug says to us that we don't have the necessary privileges because I'm not running this as administrator. But this works pretty much fine for C, C++ binaries and so on. Mimikatz is written in C++, so and we can also pass arguments. We can say, for example, coffee exit. I don't know if both. Oh, this was one mistake. I have to load it again into this variable. Coffee exit. Let's see if this works. Coffee is wrong because there's one more E. So we can also use this to execute different commands or to pass different parameters to Mimikatz. And if we pass an exit at the very end, then it will exit. So we can use something like privilege debug, SQLSR, logon passwords, exit, and then it will read out all the credentials and exit afterwards. Yeah, that's how it works. You in generally just pass the PE bytes as an byte array to the PE bytes parameter, and in the most cases this will work. And we can now create a new function or a wrapper around our reflective PE injection function, which we call nice little kitty, for example. And at the very end, after the main function, we have to close this function. And inside, we can embed our newly created Mimikatz string. Nice little cat is this string. And to decode that and decompress that, we can use the code from PowerSharpPack, for example. We just created a new... Oh, I did something wrong here. And this is the byte array. So I'm gonna put this here, which is the Mimikatz string. On this point. So we are replacing our sharp UAC bypass string with the Mimikatz string. And now this variable at the very end contains our decompressed and decoded Mimikatz binary. And we can use invoke whatever, like we just use it, to reflectively load the executable. And the PE bytes are in this case the value of this variable. And if we do that and save that, oh, I don't want it to save it as invoke whatever, but I already did that. Oh, nice little cat or kitty, whatever. So we can now load invoke. Oh, and I will do this in a new PowerShell prompt. C stream PE-injection. We have to bypass AMSI. Gonna bypass AMSI using the in-memory patch again. Invoke nice little kitty. And if we now call this script or function, we should get our from memory loaded Mimikatz version. Yeah, and this indeed works. So This, and that's many people ask me about this from time to time. Exactly this approach is what I'm doing in WinPawn, because there's one option to reflectively load Mimikatz into memory, and people ask me how are you doing that, and it's pretty much the same approach. It's just reflective PE injection with Mimikatz embedded, decoded on runtime, and yeah, this is reflective PE injection. This function here, it's obfuscated with ISE steroids, and the Mimikatz load function is the wrapper around it. And at the very end, I'm just base64 decoding Mimikatz and calling Invoke-ReflectivePEInjection with the parameter PE bytes and with the value of the decoded Mimikatz. So this is pretty much exactly the same. And this is pretty much what I'm doing here in WinPawn, because people were asking me that, and we can get a coffee there. So, Nice Little Kitty is our newly created Mimikatz version. Now to make this more stealthier and to avoid being caught by AMSI, we can use invoke obfuscation with, I think it's only two functions which we need there. PSD1 invoke obfuscation script path to our newly created Mimikatz binary is this one. Nice Little Kitty. And we're gonna replace all strings from this script with something else, because there are many triggers there on the strings. All these things, for example, vstring void, but also all these dynamic module, native, and so on. All these values, we want to replace all of them. It's 581 in this case. It's more or less, we have the option to just split them up, or to split them up and yeah, change the occurrence, more or less. We don't want to have any comments in our script, so we're gonna remove comments, because the comments also contain AMSI triggers in this case. Now I have to take a look what the other options mean. I think we should be fine by replacing arguments by just adding backticks. And now we're gonna test this. See the full path. Invoke Nice Little Kitty ops piece 1. Let's save that. Let's enable Defender real-time protection. Switch into this folder. Okay, this is still detected, but that's not a problem at all. So we need we need to make more replacements. Command. Don't want to variables. We're gonna also change all variable values because there are many variables that also contain a trigger. That was the second important one. Something like virtual alloc delegate, create remote thread, and so on. These are pretty much obvious for reflective PE injection. Create remote thread address, create remote thread delegate. Yeah, we're gonna replace those as well. And now we again output this as kitty ops. And we're good to go. It's not detected by AMSI anymore. In the case of reloading a portable executable in memory, you just need to bypass AMSI for the PowerShell script itself, because AMSI cannot analyze portable executables. It's just not built to do that. Also enabling the cloud protection now to test it against the cloud protection and or against the in-memory scanner. That worked in the workshop on Friday. Let's see if it still works here. Nice little kitty. Ah, something is wrong. That's variable replacements. Looks like the variable replacement in combination with backticks broke it. Bad. Undo, 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 undo. So with undo we can remove everything that we did so far. In this case we're gonna comment out. We will again obfuscate the string tokens. We will not do command or argument obfuscation, but we can do variable obfuscation. So string and variable are important for reflective PE injection in this case. We're gonna output this into the same folder as this with the same name. Enable real-time protection, enable cloud protection. Close this window, open up a new window. Nice little kitty is not detected. Yeah, this indeed works. We bypassed AMSI for Invoke-ReflectivePEInjection. And I cannot tell you why, but we also bypassed the in-memory scanner. Maybe because this is an older version of Mimikatz, 2020. I don't know, I can tell you. but in this case it's not detected. Normally, Defender also only Defender also detected the Mimikatz binary in memory after obfuscating it with my bash script, and so far Defender was the only one triggering it and finding it, and they only did that after I published my blog post. So before publishing it, it was not detected, and afterwards they added new strings. But in this case, it's not detected, which is fine. So it's pretty much the same, which I did on Friday, and it still works the same way. Yeah, that's how to use Invoke-ReflectivePEInjection and how to build your own custom Mimikatz binary and load it into memory, ready for usage. Other people asked me if this or if Mimikatz can maybe be detected after reading out credentials via SQL logon passwords or something like that. And I can show you that this is not the case, because at least Defender seems to scan for Mimikatz, but there are no protections or privilege debug SQL logon passwords. This is fine, and it's still not killed. So we're good to go with this version against Defender at least. So this still makes no detection. Yeah, I think most likely some EDR vendors will most likely detect this, but the question is if they build new signatures for this obfuscated Mimikatz version. I don't know. I didn't test them all, but in the most cases I was fine using this in many different environments, and even EDR vendors didn't flag for it. And if you do further modifications to the Mimikatz source code before compiling, you're also good to go, because that's what they do. They scan in memory, or they scan the payload that has to be injected before create remote thread is called. And if they scan the payload and the payload is not considered as malicious, then it will still run. So it's all about, or more or less, it's all about how good you obfuscated the Mimikatz source code before compiling it. Okay, that about Invoke-ReflectivePEInjection. There are many other cool tools that can be reflectively loaded with Invoke-ReflectivePEInjection or with another tool. The use case that I usually, or what I usually did, or where I used it for, is all those Windows privilege escalation vulnerabilities here. Most of the published privilege escalation vulnerabilities for Windows are written in C or C++. You could use it as long as you didn't use SQL. Okay. Yeah, might be the case. I had ATP only one time so far, and this one time I had no need to use this script, so it might be the case that it's still detected on runtime. But if it's detected on runtime, then maybe it or the approach to still get undetected would be, for me at least, what I would do if it gets detected is, for example, add unhooking at the very begin of the Mimikatz. So if Mimikatz is loaded, then it should at first unhook all kernel 32 and TDLL functions. And if it unhooks all of them, and if you issue all commands afterwards, then it's at least more likely to not get detected. Sure, it could also be detected by callbacks, kernel callbacks, or by opening up a handle to the LDAS process. This is most likely the case. Opening up a handle to the LDAS process is very suspicious, and this is one thing that is flagged by many vendors. But if you have that, you can use there are many different approaches of dumping LSAS with less obvious methods than Mimikatz. And you can use, for example, direct system calls and unhooking to dump it. And dumpert is also written in, I think dumpert is also written in C, so you can also reflectively load that. You could also use existing handles to LSAS, or some of the tools here use existing handles to LSAS and they don't open up a new handle to LSAS. So if that's the detection in this case, maybe the case didn't test further. Yeah, this is many times, especially for pen testers and or maybe in red team engagements at all the case that we don't have the time to test all detection mechanisms and to test all evasion techniques against them, because it just consumes much time to test all this. But there are definitely many other approaches of accessing and or dumping LSAS. And I think most of these tools are written in C, C++, so you should be able to safety dump not, but you should be able to avoid this detection from my point of view. Okay, but in this case we were also using P-Invoke because Invoke-ReflectivePEInjection is using P-Invoke. So I wanted to show one more example of not using P-Invoke to load PE portable executable into memory. And therefore I'm gonna show you again, or I'm showing one gist I created several months ago, which I used the PE-Loader from Subti in this case, from Casey Smith, and that is written in C#, and I modified it so that it's no longer using p-invoke, but instead d-invoke and or syscalls for several functions. And if you take a look at the source code, you will see that I'm using d-invoke to get syscall stuff for example, nt create thread x. And this is again less suspicious using direct syscalls than using the kernel 32 functions. Or in the most cases, this is less suspicious. There, I read about from other people. I read about detections to directly execute NTDLL APIs. I didn't face this situation myself. By using syscalls, I was pretty much fine most of the time. But people on Twitter cannot tell you exactly who and when, but I did read it that there also are detections for using direct syscalls, because EDR vendors can look up if the if the NTDLL API is coming from a legit kernel 32 function, and if that's not the case, they can say, okay, we're gonna kill this process or detect it or make a scan or whatever they do again. Yeah, so in this case, I modified it to use syscalls instead of pinvoke to load a PE. And we can downgrade the .NET Framework version. That's okay for me. I made one modification in this project. I'm not using the foodie deinvoke package, as the foodie deinvoke package is flagged nowadays by many vendors. It's a library, and this library file, if you use it, is in many cases flagged. So I created a new C# file in this project, and this contains all the deinvoke functions that are needed to make use of getSyscallStub, of the getSyscallStub function. And also some manual mapping functions. There is definitely dead code in this project, but yeah, it's less suspicious than using the foodie nugget package. The nugget package. Yeah, in this case, you just need to place your base64 encoded portable executable in this location here. And what we can do, or what we're gonna do now, is instead of gzip compressing and base64 encoding our executable, we're gonna encrypt it. Oops. I'm going to use the SharpLoader project in this case to do it, especially the Invoke-SharpEncrypt function. I can just use it. SharpEncrypt. The file we want to encrypt is C stream PowerSharpPack PE-Injection Q or Mimikatz executable. The password we're going to use is portable executable, and the out file is, let's take the same folder, Mimikatz encrypted txt. So this reads the bytes from a file, encrypts them, gzip compresses them, and finally base64 encodes them. And we have a new file with an encrypted Mimikatz version. Oh, this is just gzip. Mimikatz encrypted is this one. And instead of using just a base64 encoded version, we're gonna use our encrypted Mimikatz version. Now we don't have to just base64 decode to use that and to load that, but instead we need to decode, decompress, and afterwards decrypt. And to do that, we can take code from SharpLoader. SharpLoader is pretty much the opposite of SharpEncrypt. It can load C# encrypted C# files from a web server or something like that. And we can use, in this case, the program class, which does everything we need and embed this program class in our PE loader. So we don't need that banner for the moment. We don't need to make any web requests. We don't need to get anything from disk. We just need to decrypt. We need the cryptography library to make this work. So we have a decrypt function, but if you want to do this with a little bit more time, you can take a look at the sharp loader code and you can take the relevant parts for yourself out of it. So we need a decrypt function, we need a decompress function, we need a base64 decode function. I'm not sure if we really need the get password function. We don't need to patch AMSI in any case, and we don't need to load an assembly. We don't want to print any banner. And we don't need a main function, but we call this get back clear text, whatever. Get back clear text. And this part is also not relevant for us because we don't want to get anything from disk or from a web server. Decode stage 2. String stage 2 is args0. So we should be able to pass a string to this function. 1, 2. That's not the problem. This was the problem. Okay, so we get our bytes via parameter. We're gonna decode our bytes, our string, sorry, not bytes. We get the string as a parameter. We're gonna decode that. We decompress that. We're gonna take the password as a second argument. We're gonna create a hash for the password, which is used to decrypt. We will decrypt afterwards, and then we'll have our original bytes in this array. And we can make use of the return function to return the original bytes in this case. And then it's not a void, but a byte function. This should be fine. And if we now use get clear text back or get back clear text, then we should get back our original decrypted bytes for the Mimikatz executable. So we can use the same value here, unpacked, and call program get back clear text. We're passing the PE, we're passing a password, and the password was portable executable, I think. To be sure, I'm copy pasting it. So this is our password, and we're gonna take this byte array, and this byte array will be loaded by this is called portable executable loader. Okay. Yeah, let's try that. We don't need this. We don't need that. rebuild succeed. So we now have a newly created PE Syscall load application, which is nearly 4 megabytes big in size. Let's check if this is flagged by Defender. I don't know it. Looks like it is flagged. Oh, no thread found. Okay, this is not found. So we could also put this. Oh, did I delete it? No, I did copy it. We could also put this on the desktop, for example. Should be fine. I don't want to talk to Cortana. CD desktop PE Syscall load with everything enabled. In this case, I have to tell you one more thing. I modified the PE-Loader to sleep 5 seconds between each DLL import. So normally it's allocating every section of the portable executable. First the text section, then the RData section, the data section, PData section, RData section, and so on. And afterwards it's loading all DLLs that are needed for Mimikatz or for whatever other executable that you want to load. And this will take a long time for Mimikatz, because Mimikatz is loading a fucking load of many libraries. Yeah. In this case, we just still gonna wait. Maybe it takes maybe 1 minute or something like that to load all libraries. But if you don't want to wait such a long time, you can adjust this value, and then you're good to go with faster DLL imports. I did that because at least in the past, the Defender in-memory scanner was also triggered by too fast DLL imports in a specific row. The Mimikatz libraries, for example, are loaded in the same order every time. And if you load them too fast after another, then the in-memory scanner is also triggered, and the in-memory scanner will detect Mimikatz and kill the process. So this was one more step to avoid in-memory scans, or not the scan itself, but to avoid the scan being triggered. Let's say it like this. Okay. In the meantime, while this is still loading, we can one more time rebuild this solution, and I can show you how to we can now combine the first and the second approach, because we now have a C# binary here, and we can reflectively load this C# binary by using assembly load. First I have to check if this C# assembly is, no, it's also not found by the anti-malware scan interface. But I think that our Mimikatz binary is just flagged. Oh, what was this detection here? It was about a thread check, I think. This last detection was a thread check. So because our assembly is also not found by the anti-malware scan interface, we can reflectively load this without patching the anti-malware scan interface or AMSI DLL in memory. And to do that, I'm again PowerSharpPack using our gzip function, and I want to gzip compress our nice little assembly, which loads Mimikatz via syscalls. Now we have a text file for this assembly. See if this is loaded now. As we can see, real-time protection is enabled, cloud-delivered protection is enabled, and this file lies on the desktop, so we don't have a signature-based detection on disk. We see that we don't have an anti-malware scan interface detection for this assembly, and the in-memory scanner also didn't catch Mimikatz in this case. And we can get a coffee for that. And the ultimate answer. And exit. Okay. So this is not caught. I'm going to delete it now from here. And now in the last step, in the very, very last step, we're going to load this newly generated PE Syscall loader with Mimikatz embedded like this. We can use the template which we used in the very beginning. We're gonna call this Syscall PE-Load nice little kitty. We don't need any arguments for it. And I think we also cannot issue any arguments because the main function doesn't accept any arguments at all. But I'm not sure. Yeah, it doesn't accept any arguments. So if your assembly doesn't accept any arguments, you can delete this, and you can also, you don't need to pass any arguments. If you still pass arguments, then this will crash or at least not work. The class is public, the function name is public, PE-Loader main, and our namespace name is also PE-Loader. So we're gonna use that to make PE-Loader main, and we don't want to get all output in the very end. We want to get it directly. We don't want to put it anywhere on disk, so we can remove those 6 lines. To get rid of this trigger, we're gonna split up the magic bytes. I'm gonna save this as PE-Injection, and the name was Syscall PE-Load nice little kitty PS1. So again, as all the other times, we're going to check this file for any detections before loading it. Syscall PE-Load nice little kitty, no thread found. -e AMSI, no thread found. So this looks good to go. And we can use this to host it anywhere on the internet. Syscall Kitty PS1. And this can be loaded easily. So we have Defender enabled, we have this, that. Let's test this. IX new object network client download string. Syscall Kitty. And we are going to call this function. So, and if you see these lines, then you already know that this is working. At least it's already importing the necessary libraries, and yeah, in a pretty short amount of time, like 1 minute or something like that, we will have our loaded Mimikatz executable from memory, decrypted on runtime, without any anti-malware scan interface trigger, loaded via syscalls, sleep times between the imports. And if you're really crazy, or if you're just motivated, I'm gonna share this gist afterwards, because yeah, it will definitely get flagged after the stream, I'm pretty sure, because if you share it to others, or if some vendor analyzes it sometime, then this will also get flagged. It's only a matter of time, because I will publish it afterwards. But if that's the case, then you can the only thing you need to load it is an anti-malware scan interface bypass. This should be fine for the script itself, and then you can use it as usual. And if you want to avoid other possible detections, for example, because I'm using deinvoke in this case, and oh, our PowerShell process is killed, then memory scanner triggered. Yeah, that was at least what I was thinking in the very beginning. That Defender normally, no, that's not the thread. Defender normally triggers for the obfuscated Mimikatz version. So this won't work against Defender if you load it from GitHub at least. Let's see if it works if we load it from the directory. C stream PE-Injection, Syscall. Maybe this has also something to do with the location, if the in-memory scanner is triggered or not. Loaded via web triggers, loaded locally not. I don't know, we will see. If you want to do or to further do use some evasion or other techniques, then instead of using deinvoke, which got pretty popular in the time, and this code is not obfuscated at all, and it will not take a long time until there are many triggers for this from my point of view, because it's just the public deinvoke. A less popular and smaller way of getting direct syscalls and to use manual mapping to map the NTDLL into memory and to extract direct syscalls for usage is this repository. It has about nearly 700 lines of code, and this deinvoke version here has over 4,000 lines of code. So this is way smaller. Your executable will get way smaller, and the smaller your executable is, the easier is it to obfuscate it and to modify it so that it's not detected. And in this case, you can, there's a usage example in the C# file here. This is the usage example function, and you can load all the functions from NTDLL that you need. In this case, the steal syscall stub function will get or map NTDLL into memory and extract the corresponding functions, and afterwards you can just use them with delegates that you have to define, but they are already defined in this. So you could just replace a deinvoke with triple S, for example, and replace the get syscall stub functions here with the functions from here. Then it's at least less likely to get detected from the signature. Also modify this source code before using it. I would not use it like it is because this is public. And also from getRecBoy, there is one unhooking C# version. If you use that in addition to all other things that I'm using here, you will get additional stealth, because I have one function that I didn't port to syscalls in this case because I had problems with virtual alloc in this case. So virtual alloc is still used from kernel 32, and if you use unhooking to unhook all this stuff, then this can also not get detected by hooks. And sometimes unhooking, I had to press enter. Sometimes unhooking also gives additional stealth. How long did I stream now? 2 hours. I think I could just implement this unhooking function as well in a short amount of time. But I would need to remove several things because I think he's also blocking AMSI and patching ETV. Patching ETV is also a good addition. I did not patch ETV in this case. If you patch ETV, it will maybe also give you additional. But all these things also come with new IOCs. So if you patch ETV and if you don't set the protections back to the old value, or the patching itself can also get detected. So this all comes with new IOCs as well. Let's check that for a moment. Oh, this is wrong. We don't want to execute any shell code. Main. I don't want to use anything related to the anti-malware scan interface. So So I'm going to remove that. We're going to remove the whole function. That's easier. We don't need it anymore. Okay, patch ETV. Replace this function name. And the next PowerShell process, which loaded the script from disk, was also flagged. But I won't go further for the Defender in memory scanner at this point. But if you take a look at my PowerShell stream, then you will see at the, I think it's in the very end, I did show two ways to evade the Defender in memory scanner at the very end of the PowerShell stream. So you can use those instead. I'm gonna leave the ETV patch here. Oops. Reader. So, and I think we just have to change this function, unhook and evade ETV. We don't have any shellcode bytes because we don't want to execute shellcode. And this whole stuff for shellcode execution is also not needed. And I hope that sharp unhooker main, in this case, just does the unhooking. Don't need that. We also don't need that. Okay, patching AMSI and ETV. All those functions from kernel base, kernel 32, and TDLL, and adwp32 are all these hooks are removed in the main function. Evade ETV main. We don't need all these comments. And now we should be fine by calling PE reader. Unhook. In program. In program, we are doing all this stuff. We are doing the stuff in the very beginning. PE reader. Oh, that's not the right function name. Class name. Must be a second class afterwards. Invoke. Unhooker is the one we need. Also because this is pretty obvious. We're gonna replace sharp unhooker with a new name, and now we should also, now I'm gonna replace the sleep with a new value because I don't want to wait 5 seconds between each DLL load. That sucks a little bit. Contains an entry point. Okay, that's a problem for you. We have several main functions now. Then we gonna use entry. So I replaced all those main occurrences in the unhooking code with entry, and this is now our newly created binary, which also patches ETV. And which also does some unhooking stuff. Let's see if this is detected by Defender somehow. Nope. Let's see if this is detected by, oh, okay, it's detected by AMSI. Couldn't identify the bad bytes. So it's pretty sure that the bad bytes are somewhere here, most likely. ETVE event right. So I'm splitting this up. Defender normally triggers for ETV patches, and it triggers for AMSI patches. So if we split up the patch bytes from the ETV bypass, then I hope this is the trigger in this case. I'm not sure. What is this? Convert from case. Oh, what is this part? It's just writing down something. Gonna remove that. Let's see if this is still detected. Okay. It was luck, but exactly what I thought that it's flagged. Exactly this part was flagged. So now it's not caught by AMSI anymore, and we can again see stream PowerSharpPack gzip compress this. Input file is in this case our newly created PE Syscall load binary. Our output file. Oh, we don't need any output file. Okay. So let's take a look at that. Oh, wrong folder. This one. So we're successfully unhooking all those kernel 32 functions. Pew pew, yeah. And we get our Mimikatz binary. And now there's another difference because we unhooked NTDLL, kernel 32 DLL, and so on for the current process. Okay. All those DLLs are loaded afterwards for Mimikatz. So maybe those newly loaded DLLs could be hooked again. I'm not sure about this. I'm not sure. I would have to check it. Okay, but we have a new string now. This is the really last try for today. I'm gonna use this string. Put it into our script. And we're gonna change the magic bytes again. Save that. And try to load it. Oh, that's the wrong one. Or is it? No, it's the right one. P Syscall load nice little kitty. Okay, invoke P Syscall load nice little kitty. Let's see if this works. but I still would expect the in-memory scanner to catch this. Yeah, the in-memory scanner still catched it because it was still triggered. So unhooking and patching ETV will not prevent the trigger from occurring in this case. Just to show you how to still use that, which is not that difficult. Stream. So in a PowerShell stream, I did show up some methods to avoid the in-memory scanner, and one way to avoid it is using parent process ID spoofing. So if we spoof our parent process to arg0, arg1, cmd args. System PID command to execute. Okay. Get process. If we want to spoof our process on our parent process ID to oops, find string to Elsass, for example, we should be able to use my process, create process from parent. We're gonna use Elsass process ID because we want to spoof that one. And we want to create a new PowerShell process. Okay, it doesn't want us to do that. Now it did. Now I want to check if we really got a new parent process. Oh, I had this internal somewhere lying around. Too many windows. 2.5 hours of stream and everything is full of windows. Wow. We're gonna use Process Hacker as administrator to check it. So Elsass exe spawned PowerShell exe, and because we are now the parent process is Elsass, and now we can load this, or we should be able to load this without getting detected, because this in-memory scan is only done if the parent process is Explorer exe, which is the default for PowerShell. If you open up a PowerShell window from... Wow, they changed it. Okay. In my last stream this worked. Seems like maybe because it was embedded in the stream, they changed it, and the parent process ID spoofing is not working anymore. Okay. I had a second method in my last stream. So the question is now if Microsoft is looking at my streams. So if we copy PowerShell into another location, and if we open it up from that new location, yeah, I think They are watching it somehow. The second method still works, at least. So if you copy PowerShell into another location, and if you load something from that new location, then the in-memory scanner will not get triggered. But seems like parent process ID spoofing is not the way to go anymore. Okay, we cannot choose calculator as parent process. Let's see if we come from the YMI process 4636. It's also not working. Maybe I need system rights to do that, I'm not sure. Oh, that was wrong. Look on 6388. Okay. Seems like parent process ID spoofing is not the way to go anymore. Yeah, that's it for today. Everything that I wanted to show. How to use portable executable loaders. How to build your own PowerSharpPack binary. And in addition, I did several other things that I didn't plan to do, but looks like it was still interesting for some people because there are still some people watching. Okay, I'm gonna upload the new version of this Unhooking, ETV patching, Syscall PE-Loader, Mimikatz version into this gist. And then I'm gonna share that because I think it will get flagged anyway now, maybe from other vendors as well, because it's somewhere public after this stream. And it was not that much work, to be honest. If you think of 2 or 3 hours now, plus some extras that were not planned. I think it's pretty easy to do that again, and it's also easy to obfuscate this C# project afterwards to change the signature. And if you read the obfuscate Mimikatz blog post again, then you will see that I mentioned several more ways on how to make your own custom Mimikatz even stealthier. Yeah, if you don't have any other questions left, I would finish this. You're welcome. It looks like they are watching. At least after publishing blog posts, they were pretty fast. It was under a day, and they changed their detection methods and signatures to catch everything that are published. That's really, at least Microsoft is really fast at adding new signatures and adding new detection techniques. It's not bad. Good. I think there are no more questions, so see you next time.